Hello everyone, my name is Nicoya, and this is the Realistic Concert Mate MG-1, also known as the Radio Shack Moog. This is a pretty neat synthesizer. If you want to get into Moog on the cheap, you find one of these for sale on eBay or a thrift store for preferably under $500, and you got yourself a fun little keyboard. Now, that assumes that it works, which this one does not. It's also, missing a lot of knobs, and the ones that are here are kind of ugly. But we have a solution for that. Bigger problem, though, is that it does not make any noise. Now, obviously I have the entire mixer down, so nothing's going to sound. If I turn the square wave organ on, we do get some sound, so that's good. And if we turn the noise oscillator up, oh yeah, I'm on continuous here. So we get some noise out of that, although the noise is kind of terrible. If you hear the pulsing on there, that's actually just a problem with the chip that they used. It's just a really bad noise, white noise source. So nothing we can do about that now. I might address that in the future, but it's working. It's as good as it ever was. Tone 1 and tone 2. Nothing, except for a little bit of scratching on the knobs. Bell tone, also nothing. So, first thing to do, there's two circuits in the keyboard. One of them is for the square wave organ. That's obviously working. The other one is a gate in volts per octave. So we can check the gate. If we turn noise on and turn the contour on. So the gate is working all the way across the keyboard. That's good. But we're not getting anything out of the oscillators in terms of volts per octave yet. We haven't seen anything about that. We can check the volts per octave, though, by oscillating the mixer. So we turn this up to maximum. So we are getting volts per octave into the filter. So let's look at our block diagram. So here we see the mixer that we were playing with. Tone source 1 and 2 go into the mixer, go into the filter, sorry, I should say. The filter goes out into the amp and out to the master volume and everything. So that all works. Epiphany works. Bell tone, I believe that one does not work. Filter was ringing. Yeah, bell tone does not work. That's kind of expected for the fact that the tone sources aren't working. And now having both tone sources go out at once is a little bit weird, and so we want to look at something that is common to both of these. So we have the track and hold. Now this one goes off to the filter. So the filter cut off keyboard tracking, which goes through this switch right here. That was working. So this line that goes up here and all across here to the filter control, that's working. So we know we're good up to here. We do not have a great sample and hold here. So if I turn this on to, turn that up, turn this on to continuous, you can probably hear that the pitch is slowly rising. So that's not great. That probably means that we have a leaky op amp here, but we will look at that in a bit because it's possible that something else in here is a little bit funny. So we know that the track and hold work. We don't necessarily know the summer works because that only goes into our inverter here, and then that's where we go off to our exponential converters, into our oscillators, etc., etc. So this is sort of our area of interest here. Now, if we look at the schematic, we can see that our control voltage comes in here, and it goes into this one, which is a sample and hold. We got the capacitor into the high impedance input of our op amp. Then this goes down into this, which has our tone source mixing. It's kind of not well organized in this schematic, but we have our keyboard tone source. We have a tone sources tuning and a tone sources modulation. So that would be the tone sources tuning and the tone sources modulation here. And they all go together into this op amp, goes into this inverter. And at the output of this inverter, we should have 1 volt per octave. So this says. We should also have -1 volt per octave here because this is just a unity gain inverter. And we should probably have 1 volt per octave over here as well. So let's dig into this and see what we have inside. So start at the back. There's one screw in the back here that if you don't remove this screw, you will bend up the case. And believe me, that happens a lot. So we will need to pull out the ones on the side here, I believe, if I'm remembering correctly. And then if we flip this back over, I think the top just lifts off. There we go. So this is what the inside looks like. We've got a sort of a keyboard controller board down here. This does all the polyphonic generation with these frequency dividers down here. I think the bell tone is down here as well somewhere. Now, when I was demonstrating this, I wasn't plugging into the rear jack because it has a Bluetooth ground connection and is not really working. So one of the other things we're going to fix while we're in here. I don't know why there's an extra bit of wire here, but at some point this was modified because it originally had RCA jacks in the back here and now it has a 1/4 inch. So we'll just go ahead and fix that up when we get to that. But we want to check the volts per octave, and if I am remembering correctly, double check the schematic. Volts per octave is coming in on the white-brown, and white-brown is going to be this one. So if we check between ground and the white-brown, then we should see our volts per octave. So let me grab my meter. So press the middle C, 1.6 volts. And then that slowly falls. In fact, actually not that very slow at all. So that's a little bit of a problem. We'll deal with that later. I want to get this making sound first. Wow, that's actually not very slow at all. Although this meter might be loading it down a little bit. Anyway, we will take this off and we will consult the schematic for a second. Where, if we remember, we are looking at, we just probed this white-brown here. It goes into this amplifier capacitor, goes into U7A. The output of that is going to be pin 1 of U7A, of U7, I guess. And then U7B is going to be our mixer. So we're pretty sure that this works here. So pin 7 of U7 is going to be of interest. And then pin 6 of U8 is going to be of interest. That's our inverting buffer here. So to find that, we're going to switch to this one. Yes. So we have U8 here and U7 here, and they are upside down from one another, so that's super. So I said U7 pin something, didn't I? U7 pin 7 and U8 pin 6. So U7 pin 7. We'll look at that one. So which way up was that going to be? So we flipped up this way. So pin 7 is going to be right over, yes, this one over here. So we press to that one, we have nothing. That is clearly the wrong pin. Unless I accidentally just turned this off. Nope, we're still on. All right. 1, 2, 3, 4, 5, 6, 7. That should be the right pin. How is that not giving me anything? Am I looking at this incorrectly? U7 pin 7. Okay, never mind. That was just me being stupid. It is pin 1 is actually up because it's like flipped like this. And I thought pin 1 was down, which it is not. So let's try this again. So pin 1 is up, which means that pin 7 is right here. And pin 7 should be minus volts per octave, which it is. Okay, now we're good. So pin 7 is the output of our mixer, our tone source mixer, I guess. And that goes into U8, which is right next to it, and that one is the other way around. And so pin 1 will be down, looking at the bottom of the board. So I will look at, I guess pin 2 is going to be the input there. So we come out here into there. So we will look at pin 2. So remind myself again, pin 1 is going to be down on this one. And so it's going to be 1 and 2. So pin 2 is at negative 10 volts. Negative 9 volts. Negative 9.6 volts. So that's not correct. Very much not correct. And that's only just going through one resistor from the output to the input. As we can see here. So we just literally went through a 10K resistor and we went from volts per octave to negative 10 volts. Not ideal. So I'm guessing on pin 6, which I'm going to double check again because I'm looking at the bottom of the board. So that should be, let's see, 1, 2, 3, 4, 5, and 6. So yeah, negative 10 volts on the output, which it is kind of sort of tracking, but not correctly. So, like I said, 6, that was the output. So pin 3, which again, double checking, that's going to be that way. So 1, 2, and 3. That is, get this cable out of there. Pin 3. That is not supposed to be minus 9 and something volts. Because pin 3, if we look at this schematic, pin 3 is going through a resistor and is going to ground. So something is screwed up with this op amp. Now it could be that this op amp is leaking a gallon of current out of its positive input, which is totally plausible. Or it could be that someone has done a modification. I mean, we're already missing one of the sliders on here, which I do have a replacement for. So I guess we'll see what we see when we open up and look at the top side of this board. So why don't I go ahead and turn the power off and unscrew some screws. So I'll also want to take off our knobs. These ones here are not original, but they are actually kind of like not half bad. I don't know if I might keep them or not. They're a little bit chunky. And try and get most of these in the center so they pull off easier. And pull off my knobs. This isn't set screwed. No, just pulls right off. There we go. All right. So there is going to be screws on the back. Yes. So we have 3 screws on the back. And then we flip this back up, and you'll finally be able to see what the bottom of this board looks like, because I haven't been doing a very good job of showing you. We got 5 screws on the inside here. Actually, I might not have had to take the back screws off. I'm not sure. I might have just been holding a little bit of little bracket in there that I will not have needed to removed. But we will see in a second, I guess. All right, so we see, obviously we're missing our slider here, which is fine. But we see right here is our op amp, and that is just a regular 741 op amp, and there is no modifications or circuit bending or anything that I can see around it. So I am guessing that that op amp is just plain dead. So luckily I planned ahead for this. So first of all, I have a new set of knobs, so we'll put those on later. Second of all, I have the new slider that just drops in right there, so we'll put that on in a second. Then third of all, I have an op amp. Now, this is a 741 op amp, and the only thing good about the 741 op amp was that it was available at the time that this board was made. And really, there's nothing else good about it. So I have decided that I am going to not spend 5 cents on a 741 op amp, because nobody should ever spend actual money on a 741 op amp. I got instead an LT 1012 from Linear Technologies / whoever bought Linear Technologies after this. This should have, obviously, every specification is pretty much better, other than, Analog Devices, that's who bought them. Other than possibly the output current, but I don't think that should be a limiting factor here today. So with any luck, I should just be able to swap this in and this entire thing will come to life. We'll see, I guess. So step number one is getting this out. Now, on the back side of the board, I was noticing over here that it looked like at some point someone had done some modifications in here and the PCB traces had come up. Although the PCB traces look good over here where someone stole the slide potentiometer. So I'm going to try to be a little bit cautious with desoldering this. And in fact, I bought myself a fancy new toy. I got myself a Hakos desoldering gun. So I am going to see how well that works at desoldering. I'll try to make sure you're actually in view here and not have it sliding off onto the floor. So let me plug in my desoldering iron and make some space to set it up, and we will swap out an op amp. Oh yeah, check out this bad boy. We're gonna put some miles on this. Woohoo! Let's get this thing warmed up. Now, as per usual, we will want to get a little bit of flux on this. And as per usual, we want to make sure we're actually desoldering the right component. Yes, U8. All right, so see how this works. Ooh, I like it. Beauty. I'm happy about that. So, will this just wiggle right out? Oh yeah, perfect. Look at that. Oh, I love this thing already. All right, out with the old and in with the new. I'm going to turn this off before I burn myself. And in fact, I'm going to go ahead and set it aside because we are done desoldering for right now. All right, so get our new chip out. And we'll make sure we install it the right way around. So pop that in there nice and carefully. Of course, the legs are sprung out a little bit, as they usually are, which means it's slightly annoying to get in, but once it is in, it will stay in. Perfect. So that, and just push this up to make sure it's all the way in. Good. And solder the rest of them. Perfect. I love it. And while the iron is hot, we will strike with the tone slider, the detune slider. And it looks like they took a little solder out of that pin too. Why don't I juice that one up while I'm here? There we go. Yeah, this only goes in one way, thankfully. Yeah. I am going to have an interesting time soldering this because I need more hands. Let me see. If I grab a bunch of solder on my soldering iron and do like that. Yeah, that'll work. That's a little better. It's in there pretty firmly now, so. Perfect. So, hopefully that is all we will need to do to this board. Hopefully. Other than, you know, clean the flux off. Although apparently they didn't do that in the factory, so, yeah. Interesting, there's a few scratches on these traces here, but I don't think they're broken, so that should be fine. Nothing else needs attention. Ah, I need to do the ground wire. Now let me move this out of the way so I can do the ground wire, which is this bundle right here. And I think it was originally like not having this extra wire in here. I don't know, do I want to keep that thing? Because this can like actually reach over to here just fine, so I'm kind of tempted to remove it. Yeah, let's get rid of it. We will not need this tiny little non-original zip tie. So that should work now. There we go. So this wire can go in the trash. And now this other wire can hopefully not burn me while I solder it over here. Maybe I solder it over there. Hang on. Straighten it out a little bit. And if you are thinking to yourself, gosh, I can't see anything of what you're doing right now, Nico. Yeah, neither can I. It's one of the problems with working in spaces like this. There we go. That is much better. Okay, that is all the soldering we needed to do. And clean up the solder splatters that I accidentally, splattered all over the place. Because we don't need these shorten out stuff when they get loose inside of here. Is that all of them? Leave me a comment if you can see some I missed. Okay, so I really wish that would stay stuck down. Yeah, I wrapped this with electrical tape so I didn't destroy myself. So, let us reassemble, I think. I'm very confident. Am I that confident to reassemble it? We'll flip the lid down at least. So, we'll get the screws in at the top here. Which means getting this board in, which means wiggling all of the bits into place. I had it, come on, there we go. Okay, perfect. I now really hope I never have to do this again. Alright, so if you're looking at this repair and you're wondering if I need to use LT1012 to do this, the answer is absolutely not. Like I said, you know, the 741 technically did the job just fine, and so anything vaguely approaching the performance of a 741, which is literally every op-amp ever made ever since then, will be just fine. I just decided to go overboard. And you know, if spending $5 on an op-amp is too rich for your blood, do not feel obligated to spend more. You can totally get a 741 and swap it in there, and it will work just fine. Also, I just realized I will have to open this up again once I want to fix the sample and hold to actually hold, because it wasn't holding. Alright, double check to make sure the screws went in the right place, and they did. Okay. Plug the speaker in the back. So. Oh wait, hang on. Okay, interesting. Nope. There we go. Okay, that's not sounding great. Definitely needs an alignment. I'm going to leave that for a future video though, because this is now making sound out of both oscillators. See, that one sounds pretty octavey. Obviously the switch is a little bit diffy, but this one, not so much. No, so oscillator 1 is bad. Oscillator 2 is good. Not perfect yet, but we're getting there. So, I hope you enjoyed that video, and I will see you on the next one.